Broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, good afternoon, good evening, wherever you are in different parts of the world. This is the Krishna Vadula from IUCE representing IFES and GDC here. Thank you all for joining. Another exciting webinar for all of you from Quanser in Canada. As you can see from the title, Post-Pandemic, a Hybrid Lab Experience by Paul Karam, Director of R&D from Quanser. Over to you, Paul.
Thank you, Krishna, and thank you for yourself and Hans for hosting this wonderful event and giving us a chance to connect, albeit remotely right now with everyone that's on the line. And good morning, good afternoon, and good evening to everybody from around the world that you are. And what I'm hoping to present to you today is some of the experiences we've had at Quanser in working with many academic institutions, and really hopefully by the end of it I'd like to leave you with an optimistic message, because we are actually seeing how things are, there's definitely light at the end of the tunnel, and we're seeing how we can go back and what a post-pandemic engineering education and hands-on lab experiences could look like from some of the things that have come to light sort of in result of the pandemic that we don't want to necessarily throw away. So I'm going to get started. And for those of you who might not be aware of who we are, our company is called Quanser. We are an academically focused company, and you can see it right by our name, where we're about engineering education and mathematics and sciences in our DNA. So the name Quanser actually comes from question plus answer put together, and that's where we come from. We are solely focused on the academic market. We have been in this business for over 30 years now, and we have essentially traveled the full globe. We sell to pretty much every engineering granting program around the world, and have been doing so for many years. I wanted to give you also some more insight into our beliefs and what we do as engineers ourselves. A big part of our DNA from the very first product that you see on the left from 30 years ago is also something that we really still hold near and dear in our most recent product, and that's the Q drone on the right. So everything that we stood for from the beginning, giving students those hands-on experiences with real products, but at the same time making sure there's a direct connection to the theory that they're learning in the classroom, and really being able to bring that theory to life when they interact with our products in the lab, be it for teaching or research. In terms of what we do, these are sort of our tenets and our pillars that we design all of our products around and make sure all of our solutions encompass. It always starts with a robust and expandable hardware platform. So we make sure that our hardware can stand, is student-proof. We like to joke, and can stand the test of time. We're also have always been very adamant on open and transparent architecture. I'm sure many of you, have that experience. The PC revolution about 30-40 years ago really exploded, and back then we jumped on the PC train, and we really leveraged the great computing power that was becoming on everyone's desks and in everyone's lab station. And by using that, we were able to leverage sophisticated engineering tools like MathWorks, MATLAB, and Simulink, for example, to give students an open and transparent connection to the physical plant that they were interacting with, be it for their teaching or research purposes. We also make sure that everything that we provide is fully documented. So a lot of what you can find from a Quanser solution is a fully documented experience, meaning be it an undergraduate lab where they're going through the process, or they're building the next self-driving car and want to have some examples of how to detect objects or stay in a certain lane, for example. Like I mentioned right off the top, our sole focus is academia. We don't have a business outside of academia. Academics is our business. It's in our DNA. It's who we are. We truly enjoy working with engineering educators and researchers from around the globe, and that's where we operate in. And what we like to do as being, quote unquote, that industry, if you will, partner, we want to make sure that what we are bringing to the table is also forward looking and leveraging some of these great engineering techniques used in industry, things like model-based design and rapid controls prototyping. So at the end of the day, this is really, what we've stood for 30 years, is that we promise our customers, the professors and administrators, academic administrators around the globe, that we will stand by them and drive together towards success. And whatever that success looks like. Success for some could be, teaching some basic concepts, difficult mathematical concepts in the areas of controls, robotics, mechatronics, but bringing those concepts to life to be at least make them that much closer for the student to experience in an undergraduate setting. Or success could be, a breakthrough in research and stability of a drone, or being able to have multiple unmanned systems coordinate a task together. So it really depends on what the success is that you're looking for. And we want to make sure we're providing everything we can to make that happen. So our existence in engineering education and research is really has a duality to it. So first and foremost, a big part of our business is that research acceleration. These are tried and tested platforms that, because of their open architecture and expandability, really allow researchers to push the limits and accelerate their research to achieve breakthroughs within their areas of discipline. And also the flip side of that is teaching, and above just the teaching for singular courses, we've now been involved with many, and this is just a sample of some of the organizations around the world, where they have an impetus to transform their program. Probably one of the best examples of that just now is what's happening in McMaster University, fairly close to us in Canada. And they have launched what they're calling the pivot, and really they've pivoted the way that they deliver engineering education, where they've basically disrupted the whole first year experiences and made it much more project-based learning and much more team-based experiences, really bringing hands-on education right from the start, from first year. So we love to work with institutions that have an ambitious goal in mind, and we'll do what we can to help them achieve that goal. So some of the things that you can typically find with like I was saying, with many of our products, is all that support to go with it. So we have many experiences, we call them, or labs, if you will, for the undergraduate that you can use right off the bat, or as a professor can use it just as an example to develop their own content over and above it. And at the end, pre-pandemic and obviously moving through the pandemic, this is again what we stood for. We wanted to bridging the gap between theory and practice. And the way we position that is, you as professors, as educators and academics, you would do a fantastic job of delivering the theory, delivering the lecture, and really giving students that great content in the lab, in the lecture, and at home with all the content that you're providing them. And what we do is we come in and give you experiences in the lab that you're able to actually take those concepts and realize them with a hands-on experience. And that's truly what we've done for 30 years. And our philosophy is that this should be done continuously. Once you come and you learn something in the classroom and you go and see it actually, come to life in the lab, that really allows you to go back into the classroom and continue to build on that. And this is a great, cycle of learning and discovery and engineering, really, because without the physical experiences, it's really challenging to get a full, a fully rounded engineering experience, especially in undergraduate education. So typically, and this is a very fast video, I've sped it up about 8 times, but this gives you a very quick overview of a typical experience. I mean, a lot of this would be guided in terms of our experiences that we provide the students, but typically we're giving them a hardware product that you see on the top right there, and that's one of our introductory products. And the students, probably not this fast, but the students are expected to go through the lessons and learn, and really make the connection between, for example, here I'm changing gains on a PD controller. Previously, I was comparing it to the transfer function that they would have had in the lecture. And so this would be a typical experience that, pre-pandemic, many introductory students in controls engineering would go through. And this is what we always strive to do, is provide these types of experiences, these types of aha moments where they can really bring those concepts to life. And then the pandemic hit, and this from our many customers and partners around the world was a resounding question that came to us in April, May, June, as the reality of this global pandemic really sunk in. We were challenged with a response to this, as much as we truly believe and will always believe that engineering requires physical interactions with hardware, with systems, with experimentation. Right now, clearly, that's not possible. Many schools are still shut down, are in lockdown. Students are not back on campus. They are not back in the lab, making that physical connection really challenging. And so what we did, that some of you might have already been aware, is we leverage a lot of our IP that we've had in the company for quite some time. We just hadn't brought it out to the forefront and put it all together. And basically, aside from our stellar hardware that we've been working on for 30 plus years, and our real-time control capabilities with our software that allows you to take MATLAB, Simulink, Python, C, and actually realize it on hardware. We also have other IP that we brought to light in the pandemic and truly accelerated developments. And what I'm going to show you now is what we've currently been providing all our customers who aren't able to give that physical experience to their students. We have provided a very similar, if not exactly identical experiences, but virtually. And then what I want to get to by the end of this webinar today is something that we've realized working through this is, at the end of this pandemic, I think it'll be amiss if we just go back to only physical, because we've realized that there are other positive elements, but virtual alone doesn't completely answer the question either. It doesn't give that true ingrained experiences that the physical labs, that being there with your classmates and your colleagues truly provides you. So we truly believe in a hybrid solution. That's what I want to show you what to get to. But for now, let me show you what that virtual experience is. And what we did is released a full line of products that we're calling the Quantum Interactive Lab solution. And within that umbrella, it's basically our same physical products, simply virtualized. So instead of it being physically on your desk, it's virtually on your screen, but the whole experience is the same. And then that's a very important element of our approach with this, because we actually intended the same code, even because you even call the same device drivers, to access the hardware signals and to drive actuators in the hardware as well, because we want the same code to be able to be deployed after the fact on the physical product. And so what we're seeing coming, through this pandemic, and once we finally get through to the other side, we don't want to get rid of this virtual experience, because there's a lot of great benefits of giving students, empowering them actually at home to be able to do a lot of the sophisticated engineering development and design on their own, but then come and have the full benefit of the physical experience in the lab. So here's another very sped up video of me basically doing the same thing that I showed you in my previous video, but previously it was on the physical cube, and here's that exact same experience on the virtual cube. And I'll let this go fast. I don't want to dwell on it too much, but here is the exact same experience that I typically do on the physical cube, except now I'm doing it on the virtual. And we've really painstakingly made sure that the model of the system, all the behavior of all of our products, mimics the physical almost identically. I mean, to some very, we went to some very nonlinear lengths to make sure that all of its behavior is the same. And then the benefits of doing something like that is this code that I have in front of you. I can simply flip a switch inside that virtual cube block over there, and just say, instead of targeting the virtual, it will target the physical, and then I'll get the exact same response. And so this is kind of where we're getting to with that hybrid approach, where The experience is essentially the same, knowing full well that it's still not as good as the physical, but the benefits of students having this experience virtually at home, self-directed on their own time without having to schedule time in the lab, it's a lot safer. You can make a mistake and a drone won't hit the ceiling or crash. So there's a lot of benefits still with allowing students to still have this, but it's not a one or the other, but it's one and the other. And that's truly what we're finding as a lot of our customers and partners are working with our virtual products, but still have all the intentions to go back to the physical labs once they're allowed to do so safely. But let's not forget that now the virtual experience is quite powerful as well. Here's another example of us as we are developing the models and validating the models. Here's both my physical pendulum, in this case, it's a more advanced hardware experiment, actually running hand in hand with the virtual. There's going to be a few discrepancies, but even those discrepancies we're actually modeling and putting into the system. But the purpose of all of this is once they come into the lab, to have the same type of behavior. So if something works in the virtual, it should work in the physical, and the contrary is true as well. That if something doesn't work in one environment, it will also not work in the other. So when you're doing something like a pendulum and wanting to have some fun with, can I swing this up automatically by itself and catch it? It's probably a more satisfying experience because you're not so worried about things not going exactly right, and you tried it over and over again at home, and once you got it working, you come into the lab and you can amaze all your friends and lab mates to see, look what I was able to accomplish just by having this the full experience at home. Here's another example of something similar. So this one is a more advanced robotic manipulator. And here we're showing it, again, just as we're developing the models, but basically going through the same experience. So this is our Q-arm that was just released. And here it's going through the same motions. In this case, the physical arm, again, there's nothing there to replace it, but the benefits of some of the developments we're doing with the virtual experience is that we can now add more interesting environments, things for it to pick up, things for it on a conveyor belt, boxes for it to sort one thing or another, where to set that up repeatedly in the physical lab is sometimes a bit more challenging. So again, we're seeing that duality where as much as powerful as the physical lab experience is, there's something there and something actually quite beneficial and complementary when you have a virtual experience with it as well. But I focus quite a bit on sort of the teaching or undergraduate experiences of our solutions. But what I've come to find as I'm now set up in my basement and developing our products and our applications from my basement, there are as many research applications with leveraging this type of paradigm. And so, for example, I'll just show you a simple lane keeping algorithm that I've been developing for our self-driving car, the Q car. And here it is driving around in my basement. You can see the hockey net there that every Canadian basement absolutely must have. And as it's driving around, it's trying its best to keep in the lane over there. And the benefits of taking this and having a virtual experience is now I can actually take that same code and run it on my virtual car. In this case, it's actually a virtual mobile robot, but the same fundamentals are there. It has a camera that we are simulating from the virtual world, and you can see that's sort of the camera feed plus depth feed over there. And then based on that, I'm processing that image with the same algorithm that I was before and trying to navigate this maze as quickly as possible. And so, there's a lot of things that I was able to glean from my algorithm, things that weren't exactly working on the physical product, I was able to refine and tune on the virtual environment before going back to the physical. And there was a lot of back and forth, and I found that really beneficial and allowed me to accelerate my development there as well. So it's beneficial not just for undergraduate students, to have those at-home self-directed aha moments, but also for research groups that, again, might not have the ability to go back into the the research lab, or simply want to continue working at home. I'm sure many of you have researchers that have to share equipment and get in line to use a certain platform. This sort of democratizes or frees yourself up from some physical limitations. Again, we truly believe that there's nothing will ever compete with physical systems. Engineering is a physical science, and it should always, our belief is that it will always be there. That's sort of in the definition of being an engineer. But these are some tools that we sort of backed into, if you will, because of the pandemic, or accelerated their developments because of the pandemic. And we want to make sure that post-pandemic, the two can really come together. So I wanted to sort of summarize now and allow for questions, because we are a global company, and a lot of you, as a global audience. So I'd love to hear your experiences and what's working and not working for you. So I'll sort of summarize where we are now, and then I'd love to open it up for a question and discussion. So like I said, I want to be a bit of an optimist here. I think we might be seeing some cracks at the end of the tunnel, where we will get through this pandemic. There will be multiple options for vaccines, and there will be a return of quote unquote the new normal. And what should that look like? And so what we're feeling now is, once we get there and students are back in the labs, are back in the undergraduate teaching labs or the graduate research labs, we want to augment those experiences with the same virtual labs that we're now providing, because they can't get to the labs. And so we really think that duality of virtual and physical, sort of like that image that we had initially pre-pandemic, now actually takes on an even deeper meaning, because there is the concepts in the lecture, then there is the physical lab experiences, and then there's the democratized virtual lab experiences that you're providing students at home. Some other things that we've learned as Quanser, because we are, like I mentioned, in a very interesting position, a privileged position, the way I've captured it there, of being right now connected to so many of you that are going through a difficult time in providing, trying to deliver your courses and research remotely. And we're being able to, in real time, see what's working, what's not, and what can we do to help you achieve your goals as seamlessly as possible, given this, the pandemic that's in our way. And so, as we continue through the fall and the winter, to have, fairly remote or virtual experiences, we will be in a much better place to see what works and what doesn't, so that when, life does start returning back to normal, we can put forward a suggestion to all of you, or how do you now augment the experience to even make it even better than it was pre-pandemic. So I think that's again, an optimistic vantage point, and something that also, it's funny, at the beginning we were concerned that now we're, previously we would sell to universities, and the university would be responsible to implement the sophisticated engineering software on their own IT managed systems. And that was, fairly straightforward. Whereas now, to get this full experience, students have to do a bit more work in setting themselves up and making sure that they have, an okay system at home that can allow them to run some of these experiences themselves. But the benefit of that is that now they have a sophisticated engineering system at home, and they can do engineering by themselves at home. Once they start going, then, for us, it's no longer, we don't see it as an impediment, but really it's an empowerment for them. They're actually now, quote unquote, doing engineering at home. Part of being an engineer is to know how to set up a system, know how to install software. It's as seamless as, we might take that for granted. It's, some engineering software is not easy to install and configure and make sure things work together and optimized. And that's part of being an engineer, is making sure you can get yourself set up. And so I think that's actually another advantage that we don't want to lose once things go back to normal. You want to give them the option that if you have students or researchers that want that empowerment to be able to self-direct and continue their work at home, like many of us probably would have had we had the chance, then now they can, and there's a platform for them to do so. And then finally, putting it all together, we learned something new from this pandemic, and we're still learning, and that's why I'd love to hear your feedback and your experiences right now. But we truly believe that once this is behind us, there's no question the physical experience is paramount, but complementing it with virtual hands-on experiences at the same time, or providing both options, is truly a solution that is greater than the sum of its parts. And with that, I always like to leave it off with this slide showing a collection of our customers over the years, and really, what we pride ourselves on is that our customers view us not just as vendors, but as colleagues. And we'd like to continue that, and hopefully our work, especially now the last 6 months through this pandemic, and really, rolling up our sleeves and trying to do our best to support you in, in the challenges that you face, trying to deliver your amazing programs remotely, will make this an even more resounding statement. And with that, I will open up the floor to questions. Thank you very much, everyone.
Okay, that's great. Terrific. Paul, thank you so much for a very, very enlightening webinar here. So let's wait for a few people to start pumping in questions. Let's take a few minutes here. Hans, you want to chat for a bit before that as we wait for questions to come in? Comments, questions coming, guys?
Can you hear me?
Yeah, we can hear you. Yeah.
Paul, I just want you to know that Krishna and I deeply value the partnership that we've had for years with Quanser, and your presentation and the quality and thoughtfulness thereof just exemplifies that. And I really want to, thank you for that personally. Our friends globally who are participating. Number one, I want to ask you to put on your agendas the virtual global conference that we are diligently preparing for in November. Very important, the engagement of colleagues throughout the world, all 6 continents, not only faculty, certainly the deans, our corporate friends and colleagues, but students are vitally important, and I think we'll have several hundred students. I'm very optimistic. So I just wanted to put this on your radar screen. The other thing, building on our successful webinar series in partnership again with IUC, with Krishna, IFES, and GDC, we also have a webinar series for the Latin American community in Spanish, and this particular Friday we'll be focusing on the book Rising to the Top in our office in Latin America. But a key part of the webinar this Friday is to honor our dear friend and colleague, Lueni Morel, who passed away recently. We've put some things on our website. Please take a look at that. She's a friend deeply. And I just wanted the global community, because she's been had been part of the global community most of her life. I just wanted to mention that. And Paul, many, many thanks for your thoughtful presentation.
No, thank you so much, Hans and Krishna, for hosting us. And like I said, we're here to help, and we look forward to navigating these challenging times along with our great colleagues around the world.
Okay, question. A couple of questions regarding. Is it possible to try out what you said? Experiments remotely. Is there remote setup that can be used?
Yes, for sure. So if you just go to our website, www.quanser.com, and you'll be presented with a free trial option. So just go through that process, and we can get you set up. We have about 8 products right now that we've virtualized with this experience. And so please help yourself to our website. And if you have any questions, please feel free to reach out directly to me, Paul Karam. So it's paul.karam, Karam, @quanser.com. So that's another option as well. But our website should have all the information you need as well.
Okay, we have quite a few people here from India. So the question is, what kind of presence do you have in India? You showed a lot of partners in in the US and Canada, other places. Do you have any partners in India that somebody maybe can visit and take a look at and get some ideas?
Yeah, for sure. We work actually quite a long time in India that we've been there. We haven't been able to travel there of late, but because of the pandemic and all the restrictions. But typically, many of our staff visit India regularly, a few times a year. Probably VIT is probably one of our biggest customers of late, and that's a great place to go. But we have many installations around the country, actually, in many different provinces of India. So again, I can put you in contact with our representatives in India that can point you in the right direction should you have any questions. So please reach out to us either online or myself directly, and I'll make sure I'll put you in all the right connections.
Okay. Another question about the remote lab. How many students can access it? The trial that you have in mind, that remote labs?
So great question. So because our decision was nuanced in the sense that what we did, our answer, because everyone was scrambling again in April and May, June. We virtualized our lab. So it's because of the virtual nature of it, meaning that there isn't hardware necessarily tied to it in the back end, you can actually have multiple instances of this. So there really isn't a limitation of how many students can access it at once. So that's part of the platform that we developed, is make sure there is no limitations of seats, for example. How many actual physical products are running.
Now, when you sell your products, are they sold to individuals or colleges as a whole? What kind of a subscription do you have?
Yeah, so for our standard products, again, pre-pandemic, our business was predominantly, hardware sales, and so we would sell, a research studio, for example, in the case of the self-driving car research studio, or the more introductory sort of laboratory undergraduate experiences. So we usually sell it as a solution, as a single solution. Typical installations are, 6 to 10 stations per lab. That's typically what many of our customers have, and then we have a sort of a lab solution that we provide there, and it comes with all the software you need, obviously all the hardware, all the curriculum, and a lot of content, well documented content. We have a group of over 20 engineers at Quanser that most of us really live and breathe these experiences and documenting these experiences, and so that's a big part of our solution as well.
All right, looks like we don't have any more questions. Probably all got all the information they need from your presentation. So I guess, let's see, there's another one here. Quanser add-ons with National Instruments. How do you connect with National Instruments, Elvis?
Yeah, good question. So we've partnered with many companies. So a lot of our workflows are through MATLAB and Simulink, but also we support what we call open architecture. And what we mean by that is truly any software environment can be used to connect to our hardware. And so we've worked with National Instruments, and we've actually developed introductory top boards, trainer boards that are of the similar experiences on their Elvis platform. They just simply plug into the Elvis platform, and then you have a LabVIEW experience around that. And we have, again, full curriculum there. If anyone on the line is interested in seeing sort of what our curriculum looks and feels like, it's available free of charge on our website again. So just go to the courseware section on Quanser.com, and you'll be able to find it. You'll be able to find the Elvis, the National Instruments LabVIEW and Elvis-based products there as well.
Okay, so with that, I think we need to thank you for your really enlightening webinar. A lot of good information. I'm sure out there people are excited about what they heard. So thank you so much, Paul and Quanser and Hans.
Our pleasure, Krishna. Thank you again for hosting us, and thank you, Hans, again. And like I said, please reach out to us. And these are challenging times, and we're here to help. And hopefully we can guide you in the right direction as we have. We're getting a good sense of everyone's experience around the world. So I think we're probably in a good position to help what works and what doesn't.
So, Paul, thank you very much, and stay safe. All of our friends that are joining us, take good care of yourselves, your families, during these difficult times. And look forward to see all of you again globally, physically, hopefully next year. Peace be with all of you. Thank you kindly, Krishna and Paul.
Thank you.
All right. Thank you, everyone.